Okay, now we can finally do this. Had some trouble, but hopefully this ought to work. Alright, let's see here. What options? 7.2. Okay, so we're doing 7.2 adding and subtracting rational expressions. Pretend that says rational. That's our title. Alright, so we'll start with an example as usual. We did this in the last class, but I'm going to go ahead and redo it. Example 1 in your text, which I think I didn't. Actually, I didn't do this. 3y over 5 plus x over 5. Alright, so in order to work this problem, these two have the same numerator. Right? We can see that this, well, excuse me, they have the same denominator. We can see that this is 5, this is 5, so just like when we have numbers, just like if we had 3/5 plus 1/5, we just add that to get 4/5. Here, we're just going to have 3y plus x over 5. Nothing really special about that. Same thing we've been doing. And that was part A. Alright, so part B. Alright, same lines. We got 7 over 2r squared minus 11 over 2r squared. Alright, same thing. We can combine these 2r squared, doesn't matter what the denominator is. As long as they're the same, we can always do the same thing, which is just combine them. So we just have 7 minus 11 over 2r squared, which is just going to give us minus 4 over 2r squared, which is, we have minus 4 over 2 equals minus 2 times 2 over 2. 2 divided by 2 is 1, so that's minus 2 aside. So we basically just have, so this simplifies to minus 2 in the numerator and over r squared. And that's our final result. Nothing too fancy there, same thing we've been doing. Alright, so now the same, more of the same again. Part C, we have m over m squared minus p squared plus p over m squared minus p squared. Alright, so here we just have, the only difference is now we just have a longer denominator, but still we have the same thing going on. We basically have a denominator m squared minus p squared, some denominator, and really we don't even need to worry about what it is. As long as they're the same, we basically just have, I won't even worry about what the denominator is. We'll just treat it as some box. Basically, they have the same denominator, so it's going to be m plus p over whatever that denominator was. And in this case, it basically was just going to be m plus p, that's a p, over m squared minus p squared. Now, if we look at this denominator, we can see that that's a difference of two squares. So basically, I can rewrite the denominator as m plus p and m minus p. And the denominator, the numerator is going to be m plus p over, that's a p, not a b, over m plus p. So we basically just have that end up being 1 over m minus p, which you can verify checking your text. It's coming straight out of the book. But so that's what we end up having. So basically up to this point, and we'll do one more example since we sort of aren't as limited here as we are in class time. We have 4 over x squared plus 2x minus 8 is 2x plus x over x squared plus 2x, yeah, 2x minus 8, and here x squared plus 2x minus 8, x squared plus 2x minus 8. Again, this whole thing, they're the same. You know, I wrote it kind of weird over here. I basically just have 4 plus x over the shared denominator, or the common denominator to be technical. All right, so of course it's equal to that. So before I go saying we're done, let's check this denominator and see if it factors. So we basically have 4 plus x. So let's see if this denominator factors. 2 factors of 8 that give me 2 when I add them. So we got minus 8, and I want to factor that to get 2. So let's see here. I can do 4 and 2 are definitely 2 apart. 4 and 2 are 2 apart. So basically I just have, and since we have a positive 2, we know that 4 is going to be the bigger one. It's going to be the positive, so we'll just have negative 4, negative 2, and 4. So we basically have x plus 4 and x minus 2. Right? We got minus 2 plus 4. So we basically end up having this and this are just addition in different orders, so they're the same. So what we end up with is actually 1 over x minus 2. I'm going to squeeze it in here. But that's our little final result. Alright, so let's move on to example 3. Or example 2, excuse me. Well, actually, we'll kind of skip example 2. That's just basically, well, I guess since I'm not limited on time, I can cover that also. Alright, so example 2. Basically, it sort of introduces you into finding least common denominators. Or they also call them LCDs, basically. So basically, if we take two numbers, say 4 and 6, and we want to find the least common denominator, basically it's going to be the largest, excuse me, so basically it's going to be the largest value that each one has in common, basically. Wait a minute, That's something okay. That discard. Let me pause that. Pause this for a moment. Take a break. Short intermission. Pause. I'll pause this thing. Okay. Not terribly happy right now. I just recorded a bunch of stuff and deleted all my annotations, so I gotta start over. Hopefully that doesn't happen again, considering it's 2 o'clock in the morning. At any rate, this is section 7.2, as we started last class, on adding and subtracting rational expressions. Basically, rational expressions is just a fraction. Basically, a over b, 3 over 5, 10x plus alpha squared over gamma. I mean, these are all rational expressions, basically. They're fractions. As you can see, they have a fraction symbol. So they're all rational expressions, which means root word ratio. They're ratios, which is basically what fractions are. They're just ratios. Nothing too fancy. So basically, so we'll start with example 1, which we did last class, but it's worth going over again. I think we're all a little, including myself, we're a little thrown off by that exam. So 3y over 5 plus x over 5. Alright, so basically, just as when we had, say, 3/5 plus 1/5, we'd basically just add that and say, okay, this is 3 plus 1 over a common denominator of 5. Because usually we don't have a common denominator and we want to find one, but in this case we have it, so we can just add the top. So we have 3y plus x over 5, and that's basically it. Okay, and that was part A. Alright, so part B. 7 over 2r squared. Not writing well. Minus 7 over 2r squared. And this is in your text. I think it's page 372. So basically, same thing. 2r squared. 2r squared, we got the same denominator, so we don't even have to think about it. 2r squared and minus 4, right, minus 4, so 11 minus 7 minus 11 is minus 4, or maybe I can throw in a middle step there and say equals 7 minus 11 over 2r squared, and that is equal to minus 4 over 2r squared. And of course, if I have minus 4 over 2, that's equal to minus 2 times 2 over 2, which is just negative 2, and that's going to be in the numerator. So we basically just have minus 2 over r squared. That's our final result. So let's try part C. M over m squared minus p squared plus p over m squared minus p squared. Alright, so what we have is m plus p in the numerator, and again we have a common denominator of m squared minus p squared. Now we were not quite done here, because you notice this denominator can be factored. So we may be able to reduce this fraction a little more. So let's see. We got m plus p in the numerator. Let's pretend that's an m. It's an L and m. Alright, so we have m plus p times m minus p, what we learned before, right? So I'll just go ahead and put that in parentheses. You don't have to, but it's easier to keep up with. So basically, m plus p over m plus p is 1. So we basically have 1 over m minus p. All right. So that basically is as far as you can go with that in terms of what we're actually doing. So part D. So we get 4 over x squared plus 2x minus trying to write my finger, but that's not going to work out well. Just skip to the next slide. All right, so we have 4 over x squared plus 2x minus 8 plus x over x squared plus 2x minus 8. So now, the same thing, same denominators. So we have 4 plus x over x squared plus 2x minus 8 equals, and as you can see, our denominator, we can write 4 plus x, and our denominator is 8, 2 factors of negative 8 that add to 2, but we can use minus 2 and 4 because those two add to, those are factors of 8 that add to 2x, so we basically have x minus 2 and x plus 4, which is the same as that's in the numerator, so we basically just have 1 over x minus 2. So now let's try example 2. And this actually gets into the least common denominator, basically, which is the lowest number that has both or both or whatever, the all 3 or all 5 or however many. Basically, it's the lowest number that has all of the numbers as a factor. And so basically, let's just say I have 5, 2, and 10. Well, let's see here. If I start with 5, that doesn't have, that has this as a factor, but doesn't have this. So we already failed. If I tried 10, 10 has 5 as a factor, it has 2 as a factor, and it has itself as a factor. So basically, the least common denominator is going to be 10. So that's basically the idea of finding a least common denominator. That's what LCD stands for. Alright, so just in terms of numbers, so let's just say in example 2, they give us, and I'm just going to do, I'll do part A. We have 5xy squared and 2x cubed y, and we're to find the LCD. Alright. So remember, it's the lowest number that has all these values in common, or both of these in common. So basically, I can start with the numbers. So which I just figured out for the numbers, LCD of 2 and 5. That's going to give me 10. Because 10 is the lowest number that has both as a factor. So that takes care of my number. So I know that the numeric part is going to be 10. The coefficient is going to be 10. So if I look at the x, so I can compare my x terms, and I can see that the lowest x that has both of these in common is going to be x cubed. And if I look at my y's, the lowest y that has both of these in common is going to be the larger of these two, which is going to be y squared. So basically what I have is my final result for my least common denominator for these two terms is going to be 10x cubed y squared. And that's all there is to that. Part B, they give us k minus 3 and k, and they want us to find the same thing, find the least common denominator. So again, the if I want something that has both of these in common, well, basically k is not a factor of k minus 3, and k minus 3 is not a factor of k, basically. So the lowest common denominator here is going to basically be the product of the two. So so we have k minus 3 times k. So that's the lowest thing that has both of those in it. Just like here, the lowest thing that had both of these in it, the 5 and the 2, was 10. The lowest thing that has k minus 3 and k in it is going to be k minus 3 times k. Or we can go down a line doing the same thing. But basically, notice what we did here is we just multiplied these two without even worrying about it. We'd actually, to combine fractions, we don't necessarily have to have a least common denominator. We could just have a common denominator. In this case, the least common denominator and the common denominator really are and actually, when I say there's lots of them, there's infinitely many. Basically, I can find an infinite number of common denominators. Of course, you don't want to go too big because you don't want to make a problem a pain to solve. But really, if I want to find a common denominator, let's just say I have 10 and 5. Well, let's just say I have 10 and 2. Okay. The LCD, of course, here is 10. If I just wanted to find a common denominator, I can just multiply the two and get 20. Or I can keep going from there, but basically if I multiply the two, I can get 20. And of course, another common denominator, something else that has both, basically any number that has both of these in common. I mean, 100 has both in common. 50 has both in common. So all of these are common denominators, but 10 is the lowest of those. That's why it's called the least common denominator, because it's the lowest possible one of these. So this is the lowest one, and these are all just common ones. but this is the lowest common one. So that's why it's called the least common denominator. I know it seems backwards because you're actually looking for the number you end up is bigger than both of them, but you're actually looking for the lowest one that has the two in common. But in this case, in terms of adding fractions, just multiplying the two numbers is pretty much going to be acceptable, and really just a quick and dirty way of doing it, just to save yourself some thought or time you need to. But if you find the least common denominator, you'll definitely save yourself a little bit of reduction at the end. But either way it goes, you're going to get the right answer if you do it correctly. But basically for this one, the product just happened to be the least common denominator, and it didn't. So that's what it was in this case. Because all right, let's see here. I'm not going to do C through E. You guys can look at C through E. Yeah, so read C through E, and if you have questions, ask me about it. I don't want to make this video massive, but I want to try to touch everything I can. I guess I can try. I guess I will do part E. So just through D. I'm going to do E. So in part E, we have m squared plus 5m plus 6, m squared plus 4m plus 4, and 2m squared plus 4m minus 6. And before I move on, let me make sure this has actually been recording and I'm not just talking to myself. Keep. Let's see here. Is this thing going? Yep, it's recording. Let's see here. It looks to be recording. Yep, it's going. Okay, good. Didn't know I've been going for 27 minutes, but alright. Alright, so let's continue. Good. I haven't been wasting my time from beginning. Alright. So now, alright. So here, so let's go ahead and get each one of these in a factored form, basically. I gotta bring my pen back up. Kind of an annoying way this is programmed. Alright, so here, my factors of this are going to be m, two factors of positive 6 that add to 5 are going to be, you definitely can't use 6 and 1 because they both have to be positive to get 6. So it's going to be plus 2 and plus 3. Those are really the only possibilities. So for this, see if this factors. So we have m, and plus, so it's going to be 2 and 2. And this one, if this factors, alright, a little bit trickier, but actually a 2 factors out. So really you have 2 times m squared plus 2m minus 3. So we can just go about this as usual. So this is going to be all that times 2. So basically we'll end up with m and 2 factors of negative 3 that add to 2, which is going to be plus 3 and minus 1. Alright, so let's see what they have in common already. So let's see here. These two have a x plus 2. m plus 3 here. So basically, our product, our least common denominator, needs to have m plus 3, m plus 2, m minus 1. So all of these need to be part of your least common denominator. So basically, really your least common denominator is basically, there's nothing, the biggest thing is going to have all three of these in common, because actually this is m plus 2 squared. So basically you got m plus 3, m plus 2 squared, and m minus 1 all need to be factors of your LCD, along with that 2 sitting over there. So basically what you're going to end up with is 2 times m plus 3 times m plus 2 squared times m minus 1. So basically you're just going to end up taking a product of all of them. So I think that's pretty straightforward. So basically, because this, remember, was so basically all of those need to make their way into it, because remember, this has to be a factor. This whole thing has to be a factor, not just m plus 2, but m plus 2 times m plus 2 has to be a factor, and also this has to be a factor. Now I don't need, now since m plus 2 is already a factor of m plus 2 squared, I don't need to put m plus 2 and m plus 2 squared, because these two already have a common, this and this already have a common denominator of m plus 2. So this automatically takes care of this by default. So this is actually going to be the least common denominator. And I know, and I'm realizing as I'm reading this, as I'm saying it, I'm calling this a least common denominator. It's kind of an error the book makes that I'm kind of following along with. Technically, these aren't denominators right now. They're just basically monomials sitting by, well, not monomials, but basically they're just products, or they're just basically there's no fraction, and if there is a fraction right now, they're just sitting as 1 in the denominator. But basically we're just talking about pretending that these are denominators, and we're trying to figure out what the common one is, basically. But right now, as this sits, this is definitely not, none of these are denominators. They're all technically numerators as they're sitting right now, but we're basically just trying to find the least common factor, basically, or not the least common factor. I'm sorry, all right. So now on to example 3, which I kind of slowed down on and ended on last class. Okay, so this is part 8. So now we're getting into the whole point of all of this. We have a, so we have 5 over 2p plus 8. Oop. No, that's not what we have. Sorry. Okay, we have 5 over 2p plus 3 over 8p. So we're finding, so basically for these two, for 2p and 8p, the lowest number that has these two in common is going to be, if I look at the numbers, the lowest number that has 8 and 2 in common is going to be 8. The lowest number that has p and p in common is just going to be p. So basically our common denominator is going to be 8p. So we know this is going to be 8p, which is 2p times 4 plus about to sneeze. Okay. Guess it didn't really come. Alright. So 3 over 8p. That didn't change. So nothing to worry about there. So basically we have 5 times 4. So 4 divided by 4. That gives you oh that kind of defeats the purpose. Sorry. I'm getting ahead of myself. Sneeze kind of threw my head off. Alright, let's see here. Corner options. I don't want to do that because that kind of defeats the whole purpose of what I'm doing. Not what I want to do. Yeah, so basically the whole point of me writing it like this is to avoid making mistakes. Of course, the reason I did this is that 4 over 4 is 1, so I know that I end up, I'm going to change colors here. I know that I'll end up with what I started with. It's because I don't want to change the value. So now I haven't actually changed anything. I've been careful not to change anything. So basically what I end up with is 20 plus 3 over 8p, which is 23 over 8p. Alright, so I'll be alright. So part B, we have 6 over r minus 5 over r minus 3. Alright, so we want a common denominator, and we actually already found this in the previous part. I think that was I guess that was part B, but they just changed the R to a K. But at any rate, we can do it again. So basically, the easy way to find a common denominator, in this case it's going to be the least common denominator also, is just multiply the denominators. This times this. So it's basically going to be R times R minus 3 minus R minus 3 times R. So now they're the same. So I had 6 and keep my R minus 3 in the top and the bottom. I have 5 and multiply by R. So I have 6R minus 18 minus 5R over R times R minus 3. So simplifying, that's going to be R minus 18 over R times R minus 3. And that doesn't simplify any further. Let's see. Does it? Right, yeah, that doesn't simplify any further, so that's all we have. And I'm kind of realizing I'm kind of redoing what we did last time and you guys actually got, but I guess it's not a waste to go through it again. Especially since most of you probably weren't really that awake after the exam, so I'll go through it again. X plus 1. So now, I'll find this little dot. Alright, so wait a minute. Okay, so actually we're kind of back to the easier side. So we basically just have a common denominator again. So we basically have 7x minus this entire thing. Remember your grouping. So that's kind of the whole point in them going back to this simple problem. So we basically have 7 minus x minus 2, 7x minus x over 3x plus 1, which is just going to be 6x minus 2, which is, I could factor out a 3. No, I can't. I can factor out a 2, and I need more room, so let me erase this. Alright, so that is going to be 6x minus 2. Oh, plus 2, sorry. Yeah, because I need to distribute my negative. That's minus x minus minus 2, which is positive 2. So this should be positive 2 over 3x plus 1, which is going to be 2 times 3x plus 1 over 3x plus 1, which actually just ends up being 2. So this time we actually, all of our variables ended up falling out. Alright. And I guess I'll work B also. So we have 1 over q minus 1 minus 1 over q plus 1. Alright, so here they seem like they're almost the same, but they have different signs. So remember, 2 minus 1 is not the same as 2 plus 1. So this is 1 and this is 3. So these are absolutely not common denominators. It's actually impossible for them to be the same value. Well, yeah, it's impossible. They can't be the same value because that would imply that 1 and negative 1 are equal. Let's see. So do some erasing. It'll let me, which it doesn't seem to want to let me erase for some reason. Not sure why I can't erase that little smudge. Well, at any rate, she ain't hurting Ned. Alright, so what we have is our common denominator is going to be q minus 1 times q plus 1. Just multiply them. So basically, what you end up with is 1 minus so 1 times q plus 1, so that this doesn't change. Now it's the same value because that cancels and gives you what you start with. And the same thing here. We can do 1 and then keep up q minus 1. So now we have q plus 1 minus this whole thing. Which is actually going to be q plus 1 minus q plus 1 over q plus 1 times q minus 1, which is actually q minus q is 0, so it's just going to be 2 over q plus 1 times q minus 1. Yeah, that's your final answer. squeeze down there. That's your final answer. Alright, example. Oh, no, I've done it. I do example 5. Oh, yeah, okay. I'm on example 5. Okay. So basically, I just want to add y over y minus 2 plus 8 over 2 minus y. And that's going to give me so notice these two basically, and that little squiggle is a y. So basically these almost have the same denominator, but y minus 2 equals minus 2 minus y. They're the opposite of each other basically. You see this would be minus 2 plus y. So basically all I have to do is negate one of these. So I'll just choose the first one. So I'll just have this is y over y minus 2 times minus 1. So basically I end up with minus y plus 8 over 2 minus y, which is, this could be an acceptable answer, or you can, if you're better this way, both are acceptable. Either one of those is acceptable. And actually the book has if I can get this dot to show up, what's going on here? And actually your text has it as y minus 8 over y minus 2. Now I am not going to explain or defend why these are the same. I want to let you convince yourself as to why these two are the same. And if you have questions, definitely ask me why these are the same. I want you to think about that. Why this fraction and this fraction are the same. Or if it's not, then tell me why not. Why not? Maybe I made an error. Wouldn't be the first time. Alright, so the same idea. Only thing, we just want to find the greatest common denominator, the least common denominator. So basically, we can see if we rewrite this one in factored form, we have x times x minus 2, which is actually the product of this and this, the denominators, I mean, not the entire fraction. But basically, the third denominator is just the product of the first two denominators. So basically, this, the third denominator, is your greatest common factor, your least common denominator, excuse me. So I can basically rewrite this as, I'm going to go ahead and write 3 over x minus 2 times x plus 5 over x, x minus 2 over x minus 2, which is just 1, minus 6, and this one doesn't change, x times x minus 2. All right, so now they're all common. So 3x. So basically, I'm gonna have 3x plus 5x minus 10 minus 6 over x times x minus 2, which basically is going to end up giving me 8x minus 16 over x times x minus 2. A full 8 can factor out of this, so we have x minus 2 over x times x minus 2, and what do you know, we just end up with 8 over x. And number 7 will be the last one we work for this section. Alright, so the same thing. The denominators definitely don't look alike. First thing we want to write them as products. So let's go ahead and factor. So we have n plus 4 over, see if this factors. So we got m minus Alright, so that's going to be minus 3 plus 2, and that's going to be minus 6 plus 1. Order doesn't matter there, just multiplication. Alright, so let's see here. They don't have anything in common actually. Let me double check my work and make sure I didn't. Actually, that is. Oh no. That is wrong, and this part's wrong, and I'll give y'all a second to figure out why that's wrong. Okay. Basically, this is a positive. Can I multiply a positive and a negative to get a positive? Absolutely not. So, let's see the corner options. Keep. Oh goodness. Alright, I need a moment. Hate this. Please tell me it didn't do my thing all together. That is terrible. Okay, great. I don't know how that happened, but I got a little issue to take care of, so let me pause for a moment. Alright, had some minor technical difficulties. Let me get back from current slide. Okay, so basically the factors to use, you want a negative and a negative to give you a positive, but still add to a negative. Alright, so now basically they already have negative 3 in common, so I basically need m minus 2 in this one. So I need m minus 2 in this one, and m plus 1 in this one, basically. So I'm going to do that. So then they'll have the same denominator. So basically I m minus 3, m plus 1, and m minus 2. So we have m plus 4. Okay, come on. Can't be running out of electrical ink. That's just weirdness. Alright, m minus 2 minus 2m minus 3 times, so this is going to be m minus 3, m minus 2, and also the term that I'm missing is m plus 1, or the factor that I'm missing is m plus 1, and I'm going to cancel it so that I don't change anything. It's just 1. The ratio gives me 1, so now I have all this over a common denominator of m minus 3, m plus 1, m minus 2. So I have it's going to be a bit of a mess, but basically I have m squared, let's see here, minus 2 minus 4, well, minus 2 plus 4 is plus 2m, should be plus 2m, yeah, minus 8 minus this whole other one. So we have 2m squared. Let's see here. So plus 2 minus 3 is minus m minus 3. All right. So you got to be very careful to group this whole thing together. Otherwise, you're just going to subtract the first term and make a mistake. So let's see if I can squeeze this over here. Hopefully I can. If not, I just move to the next slide. So m plus, so looking at the square terms, that gives me 3m squared. No, it does not. Let's see here. Pointer options, erase. It's really late. Alright, so let's see here. We have m, so m squared minus 2m is minus m squared, and we have 2m minus m, no, 2m plus m, which is 3m, plus 3m, and then we have 8m minus 8 minus minus 3, which is minus 8 plus 3, which is minus 5. And denominator, it's going to be m minus 3, m plus 1, and m minus 2. Alright, and this numerator, it won't factor any. You can try to, but it won't. I'll let you convince yourself of that, but basically this is your final simplified result. Well, I won't say simplified, but your final reduced result. And one last example, example 8. How much longer I got left on my recording time. I kind of limited myself to an hour. Let's see here. Alright, so yeah, I think I'll end it there. If you have any other questions, I'll answer them for you. I got this thing set to stop in an hour, so I'm running out of time on the recording. Alright, so I hope that helps you. Good evening or morning or afternoon, whenever you watch this.